Okay, so now we're going to talk about the substitution method. And basically the substitution method is if you have two equations, you're going to solve one of those equations for x or y. It usually doesn't matter which one. And then you substitute into the other equation. So make sure you substitute your result into the other equation to solve for the unknown, and then don't forget to solve for the second variable. So here, if I wanted to solve this system, what I could do is I could take this first equation here, 2x plus y equals 8, and then I could solve that for y, and I would get y equals negative 2x plus 8. Then I could take what I got there and go up here into the second equation and replace y with that value. And what that would give me would be I would have the x, then plus 3, then times my new value for y, negative 2x plus 8, equals 9. And then distribute the 3 through, and I get minus 6x plus 24. And then if you subtract 24 from both sides here, you'll get negative 15 on the right. So, and the 24s will cancel. And then x minus 6x is going to be minus 5x. So you get minus 5x equal negative 15. And then divide both sides by negative 5 to solve for x. And you get x equals positive 3. Okay, now that's only half of the solution. So you can actually plug the 3 into any one of these equations up here. But I like to plug them into the one that I used for my substitution, because that's already written in terms of y equals minus 2x plus 8. So I'll take the y equal minus 2x plus 8, and then I'll plug in for x the 3, and then I can solve for the y. So minus 2 times 3 is negative 6. Negative 6 plus 8 is 2. And so now I have both the x and the y value. So the point would be the point 3, 2. X equal 3, y equal 2. Now on this system here, I'll take the first equation, x minus y equal 3, and this time I'll solve it for x. Again, it doesn't really matter. Most of the time it doesn't matter which one you solve for. Usually just want to solve for the easiest one you can. So if I take x minus y equal 3, I can just add y to both sides, and I'll get x equals y plus 3. Then I can substitute that in here for x into the second equation. And so instead of x plus y, I have y plus 3 plus y equals negative 1. And then y plus 3 plus y is actually 2y plus 3 equals negative 1. And then if I subtract 3 from both sides, I get 2y equals negative 4. And then if I divide both sides by 2, I'll get y equals negative 2. And then again, I can go back up here and plug into this equation the y value that I got, which is negative 2. And I'll get x equals negative 2 plus 3, which is 1. So the solution is the point 1, negative 2. And of course, you can check these solutions. Okay, so here's another one that you can do. This one is already written in a good form for you. So usually when they're written where they've already solved for x or y in one of the equations, you can just go ahead and make that substitution. So here I can go ahead, since I know x equals 18 minus 3y, I can take that and plug it in here for x into the first equation. So then that would give me 2 times x, where x is 18 minus 3y, plus y equals 11. Distribute the 2 and I get 36 minus 6y plus y equals 11. And then I know minus 6y plus y is minus 5y. And of course, if I subtract 36 from both sides, I'll get 11 minus 36 over here, and the 36 on the left would have canceled. And so I get minus 5y equals negative 25. And then if you divide both sides by negative 5, you get y equals 5. And then don't forget, you got to solve for x. So I can go back up here, and I can plug the y value I got 5 in here and solve for the x. So x would be 18 minus 3 times 5, and so that's 18 minus 15, which is 3. So the x value is 3, and the y value would be 5. Now on this one, if you take this first equation and solve it for y, you get y equals minus 2x plus 3. And then if you substitute that in for the y value in your second equation right here, then you get 4x plus 2 times minus 2x plus 3 equal 12. And then when you distribute the 2, you get minus 4x plus 6. And then what happens is the 4x minus 4x, that's just 0, so those cancel out. And you get an impossible equation, 6 equals 12. So that's an equation that can never be true, so that tells me you have no solution. Now if I got an equation like 6 equals 6, then that would mean I have infinitely many solutions because I would have gotten an identity. In other words, an equation that's always true. Okay? So that's how you do the substitution method. Let me show you an application problem here involving the substitution method. It says here a concert is selling adult tickets and child tickets to a concert. Suppose a person buys 2 adult tickets and 1 child ticket for $8, and a second person paid $9 for 1 adult and 3 child tickets. Find the price of the adult and child tickets. Well, let's look at the 2 people here. The first person bought 2 adult and 1 child. So if I let X be the price of the adult tickets and Y be the price of the child tickets, then I can represent how much this person spent based on the number of tickets they bought of each type. So this person spent $2 per adult ticket plus $1 per each child ticket, so thus 2x plus 1y, and he paid a total of $8. So those tickets have to add up to $8. And then the second person bought 1 adult and 3 child tickets. So he bought 1 ticket for whatever the price that ticket is, and then 3 child tickets for the price of whatever the child tickets are, and he paid, and there's a typo there, that should be $9, right? So he paid $9. Okay, so anyway, the equation turns out to be 2x plus y equals 8 from over here, and x plus 3y equal 9 from here. And then you can solve that. I've already solved that, but you can solve this by the substitution method that I did up here on the very first one. And then you can get the solution is x equal 3 and y equal 2. So he paid $3 for each adult ticket and $2 for each child ticket. Okay, let me show you an example of a dependent and inconsistent system. I already showed you one inconsistent system up here. This one here is an inconsistent system. Actually, that should have been number 4, but anyway, that's an inconsistent system. Now, if we take 2x plus 5y equal 1 and 6x plus 15y equal 3, we can take the 2x plus 5y equal 1. We can subtract 5y from both sides and get 2x equal minus 5y plus 1. Then divide everything by 2 and get minus 5/2 y plus 1/2 for x. Well, then I can take that and plug it back in for the x value up here. And so when I do that, I get 6 times this value plus 15y equals 3. And then when you multiply 6 times negative 15y, you're actually going to get, negative 5/2 y, you're actually going to get negative 15y. And then when you multiply 6 times 1/2, you're going to get 3. And then you bring down the 15y and set it equal to 3. And then notice the y's cancel, and so you get 3 equal 3. So 3 equal 3 is an identity and a statement that's always true. So this system has infinitely many solutions. Now, since I've already shown you an inconsistent system, I'll just tell you to freeze the video and then you can work through this one. This one is very similar to the one on the left here, except I made a small change here. I changed this number here to -1, and so by changing that, you end up with, at the end, you end up with a statement that says -3 equals 3, which is an impossible equation. And that's a statement that's never true, so this has no solution. Okay, so pause the video and go ahead and read this information that's in the highlighted yellow area here, and then you can move on to, then you can play the video and see me solve this solution, this problem down here. So this example says, suppose a company sells calculators for a price of $45, so that's $45 each. The weekly cost for the company is $30,000 plus $25 per calculator, and it says find the break-even point. Well, the break-even point is where your revenue function equals your cost function. Well, since we sell the calculators for $45 each, the revenue would be 45x, and the cost function, since the fixed cost is $30,000 regardless of the number of calculators we produce, and then there's a variable cost of $25x, so that's $25 per calculator. So the total cost will be $30,000 plus $25 times x. And then to solve this, all I have to do is I'll take r equals 45x. To solve this, I want revenue to equal cost. Since I want revenue to equal cost, I'm going to set this 45x, which is revenue, equal to this, which is cost. So in other words, I'm going to substitute the 45x in for C here, and I'll get this equation here, 45x equals 30,000 plus 25x. So then if I subtract 25x from both sides, I get 20x equals 30,000, and then divide both sides by 20, and I get x equals 1,500. So we must manufacture 1,500 calculators per week to cover our costs. And if you actually want to know the cost or revenue, because they're both going to be the same, plug the 1,500 into either one of the functions, either the cost function or the revenue function, and you can find not only the number of calculators, but the actual amount of your revenue and cost is going to be $67,500. And if you were to graph those two equations, they would look like this, and you'll notice they intersect at this point, 1,500 calculators and $67,500. And if you produce calculators less than 1,500, you're actually going to lose money because your cost is below your revenue. I mean, let's see, your cost is above your revenue. But if you produce calculators more than 1,500, then your revenue is higher than your cost, and so you'll profit in that case. Now, I'm going to do this again. I want you to go ahead and pause and read this on supply and demand, and I'm going to talk to you about solving a supply and demand problem. And so let me show you an example here. Suppose we want to analyze the sale of a box of tea where Q represents the number of boxes of tea in thousands during 1 week. We have determined that the supply and demand equation are these. This is your supply equation. This is your demand equation. Okay, so what you want to do to find what's called the equilibrium point, that's the point where supply meets demand, you just take this expression from your supply and substitute it in here for your demand. In other words, you set the two equal to one another, and then you solve that equation for Q. Now, I'm sure you know how to solve an equation for like this, so I'll just go ahead and cut to the answer here because I'm kind of running low on time. So Q equals 12, and that's 12,000 boxes of tea. But if you plug the 12 back into either one of these equations, it'll give you a price of $1.60. So your equilibrium point is set the price at $1.60, and then that way the supplier is willing to supply 12,000 boxes of tea, and the consumers are willing to consume 12,000 boxes of tea. And then I'll show you, these are the two equations for your supply and demand, and notice that they intersect where the quantity is 12 and the price is 1.6. And that's pretty much all I want to talk to you about on this.